Imagine standing face to face with the very first humans. No matter where they lived, no matter what language they spoke, what tools they carried, or what stories they told around the fire. One thing would immediately stand out. Every single one of them looked back at the world with brown eyes. Not most of them, not the majority, all of them. So if that's true, where did blue eyes come from? Where did green eyes come from? Who was the first person in human history to ever open their eyes and reveal a color the world had never seen before? And here's the part that should really bother you. If brown eyes had worked perfectly fine for hundreds of thousands of years, why didn't evolution just erase this strange new color the moment it appeared? Let's go find out. Today, when you look around, you see brown eyes, blue eyes, green eyes, gray eyes, hazel eyes, sometimes eyes that seem to shift color depending on the light. It feels like this has always been part of being human. But for the vast majority of our species' existence, that variety simply didn't exist. Something changed. Something specific, something traceable, and something far stranger than most people realize. So what changed? To answer that, we have to go all the way back to the very beginning. Around 300,000 years ago, in the intense equatorial sun of Africa, early Homo sapiens were dealing with a serious problem: sunlight. Not just on skin, but on eyes too. Ultraviolet radiation doesn't just damage skin cells, it can damage the delicate tissue inside the eye as well. And the body's solution was the same one it used for skin: melanin, a dark pigment that acts like natural sunglasses, absorbing UV light before it can cause harm. Brown eyes are simply eyes packed full of melanin. And in a part of the world with some of the most intense sunlight on Earth, that dark pigment wasn't just useful, it was essential. Evolution favored it aggressively. Brown eyes protected vision, protected long-term eye health, and quietly became the default setting for the entire human species. For a long time, that was the whole story. One trait, one advantage, one color. But then humans did something no other species on Earth had ever done at this scale. They left. Beginning somewhere between 70 and 100,000 years ago, groups of Homo sapiens began migrating out of Africa, slowly, generationally, through the Middle East, into Europe, across the vast plains of Asia. And as they moved further from the equator, the environment around them transformed completely. Sunlight weakened, days grew shorter, skies stayed gray for months at a time in the deep cold of Ice Age winters. The intense sunlight that had made dark pigment so valuable in Africa was gone. And that raises an unsettling question. If the original pressure that demanded dark, protective eyes had disappeared, what was stopping something new from slipping through unnoticed? This is where the story takes its biggest turn. Scientists studying ancient DNA made a discovery that genuinely surprised the entire field of human genetics. Nearly every single blue-eyed person alive on Earth today, no matter their nationality, no matter how distant their family lines seem from one another, shares the exact same tiny genetic mutation. Not a similar mutation, not a comparable one, the same one. Which means somewhere, at some point, there was one person, one single individual, born with a genetic change that had never existed in a human being before. Researchers estimate this mutation likely first appeared somewhere between 6,000 and 10,000 years ago in a population near the Black Sea region. In the entire 300,000-year history of our species, that is almost unbelievably recent. Before that moment, there is no evidence blue eyes existed anywhere in the human population. After that moment, an entirely new eye color entered the human gene pool, and it never left. So what actually happened inside that one person's DNA? To understand it, we need to talk about two genes with strange names that turn out to be central characters in this whole mystery: OCA2 and HERC2. OCA2 is a gene that plays a major role in producing melanin. Think of it as a factory that manufactures the dark pigment that colors your eyes, skin, and hair. HERC2 sits right next to OCA2 on the same chromosome, and it acts almost like a switch, controlling how active that factory actually is. The mutation that created blue eyes wasn't a change to OCA2 itself, it was a change to HERC2. The switch. This tiny genetic alteration didn't destroy the melanin factory, it just dialed it way down, specifically in the iris. Less melanin production in that one specific tissue meant less brown pigment being deposited there. And that leads to one of the strangest facts in this entire story. Blue eyes are not actually blue. There is no blue pigment in your eyes at all. None. What's actually happening is something closer to what happens in the sky. The sky isn't blue because of blue particles floating up there. It's blue because of the way sunlight scatters through the atmosphere, with shorter blue wavelengths bouncing around more than other colors. Something remarkably similar happens inside a low melanin iris. Light enters the eye, and instead of being absorbed by dense brown pigment, it scatters off the fibers of the iris itself. Shorter wavelengths of light, the blue end of the spectrum, scatter the most. Your brain interprets that scattered light as the color blue. It's not paint. It's physics happening inside your own eye every time you look at someone. This means a person with blue eyes technically has the least eye pigment of anyone. And what you're actually seeing is closer to a structural color, similar to how a butterfly's wings can appear vividly blue without containing any blue pigment whatsoever. But this is only half the story, because blue eyes are actually one of the simpler mysteries here. Green, gray, and hazel eyes are far more complicated and far less understood. Unlike blue eyes, which trace back overwhelmingly to that one shared ancient mutation, green and hazel eyes involve a more complex interaction between multiple genes, not just OCA2 and HERC2, but several additional genetic variants that influence exactly how much melanin ends up in the iris and how it's distributed. Green eyes tend to involve slightly more melanin than blue eyes, just enough to shift that scattered blue light toward a yellowish-green appearance when it mixes with a small amount of underlying pigment. Hazel eyes are even more complex, often showing a blend of colors that can shift depending on lighting, clothing, or even the size of the pupil. Because so many genes are involved, green and hazel eyes didn't emerge from one single dramatic mutation the way blue eyes did. They likely developed more gradually, through countless small genetic variations building on top of each other. It's one of the reasons green eyes are actually rarer globally than blue eyes, found in only around 2% of the world's population. So now we're left with the biggest question of all. If brown eyes were the original protective advantage, if melanin genuinely shields delicate eye tissue from UV damage, why didn't evolution simply erase this new, less protected variant the moment it appeared? Blue eyes should have been a disadvantage, and yet, thousands of years later, hundreds of millions of people carry them. Scientists have proposed several theories, and it's important to say clearly this is still an active area of scientific debate. Nobody has a single confirmed answer. One leading theory involves something called the founder effect, combined with population bottlenecks. If the population carrying this new mutation happened to expand rapidly, perhaps due to advantages in early agriculture or migration patterns completely unrelated to eye color itself, the mutation could have spread simply by being present in a growing population, whether or not it offered any advantage at all. Another theory focuses on sexual selection. Some researchers suggest that a rare, unusual, visually striking trait like blue eyes may have simply been found attractive, and individuals carrying it may have had a slightly higher chance of reproducing, spreading the trait not because it improved survival, but because of pure preference. A third theory connects to reduced sunlight in northern latitudes. In regions with weaker sun and long, dark winters, the intense UV protection that mattered so much in equatorial Africa mattered significantly less. Without strong pressure against it, a mutation that would have been quickly eliminated near the equator could simply persist, unnoticed and unpunished by natural selection. The honest answer is that scientists currently believe it was likely some combination of these forces working together, rather than one single dramatic cause. The full picture is still being pieced together, and this is where it becomes important to clear something up. Blue eyes are not stronger. They are not weaker. They are not a sign of superiority, and they are absolutely not evidence of separate human races or distinct genetic groups. This is one single, tiny variation in one single gene, in one incredibly recent moment in an otherwise shared 300,000-year human story. Every person with blue, green, gray, or hazel eyes is descended from the exact same brown-eyed ancestors as everyone else on the planet. Which brings us back to where this story truly begins. Somewhere near the Black Sea, thousands of years ago, in a world where every single human who had ever lived had opened their eyes to reveal some shade of brown, one child was born different. Their parents would have looked down into eyes unlike anything they, or anyone in their entire family line, had ever seen before. There was no way for them to know what they were witnessing. No way to know that this one small, almost invisible genetic change would eventually spread across continents, across thousands of years, into the eyes of hundreds of millions of people alive today. Every pair of blue eyes, every green eye, every gray eye you've ever looked into carries a small piece of that story. tracing back to one impossibly specific moment in human history. A reminder that sometimes the biggest changes in the human story don't begin with something dramatic at all. Sometimes they begin with something almost invisible.